Yes friends, let's move on towards our next topic of discussion, which is electric quadrupole moment and the derivation of electric quadrupole moment. There is no need to remember the derivation of electric quadrupole moment because usually it is not asked. Okay, up to here we had already learnt, right, how to find the parity and nuclear spin. Up to here we had already seen some problems, we had already seen. Okay, now what about electric quadrupole moment? Is it important topic for the UPSC CSE physics optional? So yes, it is important, but the thing is that its derivation is not important. Okay, in some books you will find its derivation also, derivation of electric quadrupole moment you will find in some books. Okay, but it is not important. Okay, it is not important because it is usually not asked. Now UPSC is unpredictable, so always some questions on electric quadrupole moment could also be asked in the UPSC CSE examination. Some derivation related question could also be asked, but the thing is that you will have to leave that question if it comes in any. Okay, so you have any option you have already, right? Out of the 8 questions you have to attempt any 5, right? Means I think question 1 and 2 are compulsory, and after that it is either or type of thing. Okay, so it is like that. So the thing is that out of the last 5 questions you have to attempt any 3. So if the derivation of electric quadrupole moment comes in that, you have to simply skip that question and go to the other question. Okay, so usually it is not asked. Derivation of electric quadrupole moment expression, usually it is not asked in the examination, but you can certainly have a look at the various books and you can certainly derive it. So electric quadrupole moment Q, now this expression is there, which is the value of Q, that is electric quadrupole moment Q, which is equal to minus 3 by 5 into 2I minus 1 divided by 2I plus 1 RA square. Now this is for odd atomic mass number A and odd atomic number Z. Okay, this expression has been derived. Okay, this expression has been derived, this particular expression in box, it has been derived with the help of the assumption. Okay, with the help of the assumption that odd atomic mass number A is the assumption, first assumption, and odd atomic number, okay, that is number of protons is odd and atomic mass number is also odd, that is odd atomic number and odd atomic mass number. Based on this assumption, this expression has been derived. Now how this expression has been derived, I am not going to discuss it. Okay, you can yourself have a look at any book and go, for example Arthur B. Sir, you can go to in the book Arthur B. Sir, this is given. Okay, Arthur B. Sir or Arthur by Sir, whatever you call it. So in that nuclear and particle physics, if you go into that chapter, so you will find the derivation of this expression, this particular expression, but its derivation is not important as far as UPSC CSE physics optional is concerned. Okay, its derivation is usually asked in the university examinations, but as far as UPSC CSE physics optional is concerned, its derivation is not important, already told to you. Now minus 3 by 5 into 2I minus 1 divided by 2I plus 2 RA square. Now I is what does it mean by I over here? I is total angular momentum or nuclear spin. Okay, either you call it nuclear spin or total angular momentum, one and the same thing. So I is capital I is the value of total angular momentum or nuclear spin, which we have already found out till now. How to find value of I have already discussed in the previous lectures, right? Now if you haven't watched the previous lectures, then you can certainly go to the link in the description and start watching from the very first lecture. You will understand each and everything very clearly from there. Okay, because I have started from the very basics. Okay, so nuclear and particle physics playlist link is there in the description. The end screen of this video is also that only. Okay, so you can certainly watch that from the very beginning. And if you go to my channel, I have made various playlists. Okay, so you can watch each and every playlist and you will understand each and every concept very clearly from there. Okay, so this is the thing. So I is what? Total angular momentum or nuclear spin. Now what is RA? Okay, RA is your radius of spherical nucleus. What does it mean by RA? RA means radius of spherical nucleus. So RA equal to R naught e to the power 1 by 3 over here. Okay, now RA is the radius of spherical nucleus, and for spherical nucleus, what is the value of radius? R naught e to the power 1 by 3, where A is the atomic mass number. Okay, so R naught e to the power 1 by 3, that is R naught multiplied by cube root of atomic mass number, that gives you the radius of spherical nucleus. Now this particular formula we had learnt in third or fourth lecture, I suppose. Okay, in third or fourth lecture we had already learnt about this particular formula. Okay, so this is the thing. Now q equal to 0 for magic nuclei. What does it mean by q equal to 0 for magic nuclei? For magic nuclei means either the value of z, that is total number of protons, either it is magic number, or the total number of neutrons, capital N, total number of neutrons, capital N, it might be magic number. Okay, so for both the things, either z is magic number or n is magic number, either capital Z is magic number or capital N is magic number. In that case, the value of electric quadrupole moment q becomes 0. In that case, what does it what happens in that case? When z is either magic number or n is magic number, or both are magic number, z and n both are magic number. Okay, so either z can be magic number only, or either only n can be magic number, or both z and n can be magic number. Okay, so either z, either n, or both n and z. Okay, so in that case the value of q, that is electric quadrupole moment q value, it turns out to be equal to 0. Now what does it mean by magic nuclei? We have already learned in the previous lectures. Okay, so why should I tell you now? Okay, so q equal to 0 for magic nuclei. Now what are the various discrepancies which are involved in this particular electric quadrupole moment? If you want to find out, then what are the various discrepancies which we have with us? Okay, the various discrepancies are as follows, that the observed q values are large and not always negative. First of all, the q value which is observed, you can see over here, the q value of electric quadrupole moment q, it is being shown as negative. You have put the minus sign over here in the front. Okay, what have you done? You have basically put a minus sign in the front. So it is not necessary that the value of q, that is electric quadrupole moment q, it is always negative. It is not compulsory. Okay, so there are some discrepancies. Discrepancies means exceptions. Okay, what does it mean by discrepancies? Discrepancies means exceptions, or you can say deviation from normal law. Okay, discrepancy means deviation from normality. Okay, anomaly. Okay, so observed q values are large and not are negative always. That observed q values are large, not always small. Sometimes they may be large also, and sometimes they might be positive also. It is not necessary that they are always negative. Although this expression shows that it is always negative, but they are not always negative. Okay, sometimes they might be positive also. So that is a discrepancy. Okay, and please remember that this formula is only for odd a and odd z. Okay, the derivation is based on, when you derive this particular formula, whenever you look at any standard textbook and you try to derive this particular formula, then what will happen? In that particular textbook, the assumption will be odd a and odd z. Only then this formula can be derived. Electric quadrupole moment q formula will be derived based on the assumption that odd a and odd z. Okay, that is the assumption. Okay, so that is the thing. Now the electric quadrupole moment q of odd a, now the thing is that whatever expression of q we have found out for odd a and odd z, the same expression holds. Okay, the same expression holds for odd a, odd n nucleus also. Okay, so q of odd a, odd n are similar to that of odd a and odd z, although we have derived the expression for odd a, odd z. Okay, but experimentally it is found that if a nucleus has odd a, odd n instead of odd a, odd z, the nucleus has odd a, odd n, suppose. That is, number of neutrons is odd instead of number of protons, but atomic mass number is odd itself. Okay, but instead of number of protons being odd, number of neutrons are odd, suppose. So the value of q for odd a, odd n are similar to that of odd a, odd z. Okay, so the electric quadrupole moment of odd a, odd n nuclei are similar to that of odd a, odd z nuclei. This thing you must remember. Although while deriving this particular expression, we have assumed that atomic mass number a is odd and atomic number z is odd. We have assumed like that while deriving the expression. Okay, but if we actually that is while deriving the expression, the thing which has been shown over there. So while deriving expression odd a and odd z is the assumption, but experimentally it has been found. Okay, experimentally it has been found that whatever expression holds for odd a, odd z, the same expression will hold for odd a, odd n. Okay, whatever expression holds for odd a, odd z, the same expression will hold for odd a, odd n nuclei also. Okay, same expression will hold for odd A, odd N nuclei also, and the value of electric quadrupole moment for odd A, odd Z, or odd A, odd N. Okay, it is given like this. Okay, so this is the thing which you must remember. So there are two discrepancies involved in this, and no need to go into its derivation. No need to go into the derivation of this particular formula. The derivation of this particular formula you can find in any book and you can go through it, but no need to go into the derivation. See, because UPSC CSE physics optional has a very vast syllabus. Okay, even GS has very vast syllabus, but the thing is that in GS you cannot skip any topic. Okay, in physics optional you can skip certain topics. Okay, so for example, the derivation of this expression, okay, the derivation of this particular expression, as far as physics optional of UPSC CSE is concerned, the derivation of this particular expression can be skipped. Okay, it can be skipped, no need to go into its derivation. Okay, so it can be skipped. In the olden days, what used to happen before 2008. Okay, before 2008, even the derivation of this was important. Okay, before, in UPSC CSE physics optional, prior to 2008 questions, okay, prior to 2008, what was the trend? The trend was that prior to 2008 the derivation of this expression was also very important prior to 2008, but after 2008 they have basically shifted. UPSC has shifted from long length answers to short length answers from 2008 onwards. So now as far as the today's trend is concerned, no need to go into the derivation of this particular expression. Okay, no need to go into its derivation. Okay, so thank you very much. And now you guys don't like the videos, so please give the videos a big thumbs up. You guys are not at all liking the videos. It is hardly getting 1 or 2 likes. Okay, hardly 1-2 likes it is getting. Okay, so this is not a good symbol. You must at least like the videos and subscribe to our channel, because all these things require a lot of efforts, right? These things are not just something which is very easy to make, or something which is cakewalk. It is not like that. Okay, these videos require a lot of effort, so you must always like these videos. Okay, so thank you very much, and there will be one end screen at the end of this video. You can certainly watch the nuclear and particle physics playlist from the very beginning. You will understand each and every concept very clearly. So thank you very much.